All right, section 7.3, we get into function operations. And I just want to point out that, remember earlier this year we talked about function notation a little bit. I'm going to highlight some of these. How we would read those is the one on the left would be f of x, and then it'd be g of x, and then it'd be h of x. That's how we read that. It's not times, it's just the way we can write a function and kind of label it with a letter. So that would be three different functions: the f function, the g function, and the h function. So if we have f of x and g of x, which are up here on the top, two functions, we can create a new function, h of x, by doing some operations with them. So you can see the top operation is addition. So if we do addition, we would do h of x equals f of x plus g of x. So if we follow these steps, h of x equals f of x is 3x minus 4 plus g of x, which is 5x. And if we do this, we would get h of x equals 8x minus 4. So you can see h of x is different than f of x and g of x. And the next one is subtraction. So in this one, we would get h of x equals f of x, which is 3x, minus 4, minus g of x, so minus 5x. If we did our operations, it will be 3x minus 4 minus 5x. We would get h of x equals 3x minus 5x is negative 2x. So we would have negative 2x minus 4. For multiplication, we take f of x, which is 3x minus 4, times g of x, which is 5x, and we would multiply. Remember, multiplication is basically just distributing. So we distribute the 5x to both of these. So we'd end up with h of x equals 5x times 3x is 15x squared. 5x times negative 4 is negative 20x. So we'd end up with 15x squared minus 20x. Right. And then for the last one, the division one, h of x equals f of x goes on top, so 3x minus 4 is on top. G of x goes on the bottom, so 5x goes on bottom. And now, since it's 3x minus 4, we can't just reduce that and say, oh, well, there's 3 x's on top and 5 on the bottom, so they cancel. We can't do that because these things on top are together in parentheses. So this is all we can do. We can just write that as a fraction. So those are the operations we can do with functions. Okay, now this bottom box is something you've never seen before, or you probably talked about it, but not in the way that we're going to do it this section. So the domain of h of x. Okay. Domain is whatever x can be. Okay, there's certain things that x cannot be. So it's kind of like saying, like, what can you plug in for x and what can't you plug in for x? And it can be a little tricky. So for domain, we're looking for what x values are, and we're going to talk about first what they cannot be. So I'm going to write it like this. Make a little list here. So assume that x can be anything, except you cannot have an x value if it does the following things. If it, for 1, makes the denominator equal 0. Okay, if you have a x value that when you plug it in, the denominator or the bottom of a fraction equals 0, we can't have that. Okay, that's not allowed. We also cannot have an x value that makes the number inside an even radical be negative. Okay, so when you're thinking domain, think cannot make the bottom 0, cannot make a negative number inside of an even radical. Okay, in an even radical. That's important to note too, that it's okay if it's odd, but if it's even, we can't have that. Okay, so that's how we can determine our domain. X is everything except for a number that makes the bottom 0 or makes an even radical be negative. Okay, so determine the domain of the following functions. Number 1, f of x equals -2 times x to the 1/2 power. Okay, and this looks kind of basic, but really what we have here is we have -2 times the square root of x. This is a times symbol, by the way. So f of x equals -2 times the square root of x. So the first thing I want to ask you is, the number one thing we wrote in our domain is there a fraction? If you look at number 1, there's not a fraction. The second thing is there an even radical? So if you look here, the square root is an even radical. Okay, so we put D for domain. Okay, the x value cannot make the square root a negative number. So x can be everything except for negatives. So the domain is all real numbers except negatives. Or you could say all real positive numbers. Another way to write this is the domain is x is greater than or equal to 0. Okay, because you can put 0 in there and do the square root of 0. You can put a positive number in there, but you can't put a negative number inside of a square root because it's even. You look at number 2. If we rewrite this as a radical, just because radicals are easier to see when it's even or odd, but if we have 9 times the cube root of x minus 5. Okay, now if you look, we have an odd root. 3 is odd. So the domain, since it's odd, x can be anything. You can do the cube root of a negative. So if it's all real numbers, you can write the words out, all real numbers. Or you could put down the domain and then put an R like that. There's a couple ways to write it. Basically, as long as you know it could be anything, positive, negative, doesn't matter, because it's an odd radical. And then let's take a look at number 3. X to the negative first power is really f of x equals 1 over x. So now we check, is there a fraction? There is a fraction. You see the bottom of a fraction is x. So in the bottom cannot equal 0. So what we know is the bottom is x, so x cannot equal 0. We take the bottom of the fraction and set it equal to 0, and that's what it cannot equal. So our domain is x cannot equal 0. That means all numbers except for 0. Because you can't do 1 over 0. If x was 0, you would get this. And if you type that in your calculator, it's going to say error or undefined because we can't divide by 0. So that's not okay. But anything except for 0 is fine. So that's how domain works. Okay. In number 1 and 2 here, we're going to perform the indicated operation and then state the domain. So Number one, we're going to add up f of x and g of x and then state the domain. So f of x is 5x to the 1/2 power. G of x is negative 9x to the 1/2 power. So if we add these up, 5x to the 1/2 plus negative 9x to the 1/2 is negative 4x to the 1/2 power, which is negative 4 times the square root of x. So that's what we get when we perform the operation. Now let's find the domain. First thing is look for, is there a fraction? There's not a fraction, it's just negative 4 times square root of x. The second thing is there an even radical? There is an even radical. So the even radical has an x inside. So inside, we know that it cannot be negative. So the domain is x can't be negative because we can't have a negative number inside of a square root. So we'd write that as x is greater than or equal to 0. That would be our domain because the number inside of a square root cannot be negative, so it's got to be 0 or bigger. Number 2, we are subtracting. So this would be 5x to the 1/2 power minus negative 9x to the 1/2 power. So minus a negative. Minus negative 9 is really plus positive 9. So we end up with positive 14 x to the 1/2 power, which would be 14 times the square root of x. Again, we have no fraction, but we do have an even radical. So when you're doing your domain, just know what's inside cannot be negative. So x can't be negative. So for the domain, what can x be? X can be greater than or equal to 0. Because 0 is fine, positive numbers are fine, it just cannot be negative. Okay, a couple more examples here. This time we're multiplying and dividing. So perform the operation and state the domain. So for number 1, we would have 3x plus 7 times x plus 1. And then we'd multiply these out, which would be foiling. 3x times x is 3x squared. 3x times 1 is 3x. 7 times x is 7x. And 7 times 1 is 7. Combine like terms, we would get 3x squared plus 10x plus 7. So we look at this function. Are there any fractions with x's on the bottom? And the answer is no. All right. Are there any radicals, like a square root or a fourth root, any even radicals? And there is not. So if there's no fractions, no even radicals, the domain is all real numbers. Okay, and then number 2 is a fraction f of x over g of x. 3x plus 7 over x plus 1. All right, and then perform the indicated operation. So with 3x plus 7 over x plus 1, we can't really simplify that. There's no factors that we can simplify out. So we leave it like this. And now to find the domain, there is a fraction now. So if you look, there's a fraction where the bottom is x plus 1. So what we know about a fraction is the bottom cannot equal 0. So x plus 1 cannot equal 0. So we solve this. If we minus 1, we see that x cannot equal negative 1. So for our domain, we would say x cannot equal negative 1. And that would be our answer. So we perform the operation, found the domain. The domain is x cannot equal 1. Everything else is fine, just not, negative 1. Okay, and then we got two more. Perform the indicated operation and state the domain. So f of x is 6x to the 1/2 times g of x, which is 4x to the 1/3. Okay, so we would get 24 times x to the, this would be 1/2 plus 1/3. Because when we're multiplying exponents, like when we're doing this, we add the, sorry, we're multiplying bases, we add the exponents. So if we look at the fractions, there's a 2 and a 3. We want to change the bottoms into 6. So we end up with 24 times x to the 3/6 plus 2/6. Okay, and if we add them up, we would get 24 times x to the 5/6. Okay, so we performed the operation, we multiplied f of x and g of x. Now if we rewrite this, this would be 24 times the 6th root of x to the 5th power. So this is our operation we performed. Now if you look, is this an even or an odd radical? That would be an even radical because it is the 6th root. So we would end up with the domain being the inside cannot be negative because it's an even radical. So we know that x can't be negative, so x has to be greater than or equal to 0. So that would be our answer. The operation would give us 24 times the 6th root of x to the 5th power. And the domain as x has to be greater than or equal to 0 because it cannot be negative. Okay, and then number 2, g of x over f of x. So g of x is 4x to the 1/3 power. F of x is 6x to the 1/2 power. So what we have to do here is, if we simplify, it's probably easier to write this on the bottom as a radical. It's not okay to have a radical on the bottom, so we're going to get rid of that square root by multiplying by square root of x, which would give us 4x to the 1/3 times, I'm going to put x to the 1/2. Now I'm going to change that back to a fraction, and the bottom will be 6x. The reason why is because this would be the square root of x squared, which is just x. That's where the x came from. Okay, now this is kind of tricky. We're not quite done because we have to add up these fractions. So it'd be 4x to the 2/6 plus 3/6. Okay, if you're wondering where those came from, think about what we did over here. 1/2 plus 1/3 was 3/6 plus 2/6. So I didn't show all the steps, but I made the fractions into denominators of 6. So, and this is all over 6x, which is 4x to the 5/6 over 6x. Okay, now what we really have is 4 times the 6th root of x to the 5th power over 6x. Okay, take a minute to kind of process that. You can pause the video if you want. I'm going to keep going though. 4 over 6 can be reduced. 4 over 6 can be reduced down to 2 over 3. So I'm just going to erase and change this to 2 over 3 to save some room. Now, do we have a fraction? We do. You see, the fraction has a 3x on the bottom. So for the domain, we know that x cannot equal 0 because 0 would make the bottom equal 0. So x can't equal 0. We also have an even radical. So x can also can't be negative. So x can't be negative. So if x can't be negative and x can't equal 0, what can it be? X has to be greater than 0. So that one was tricky because there's a fraction and there's an even radical. X cannot equal 0.